Okay, we're simplifying radical expressions, day 2. Day 2. So we're starting over here. And we're starting with a little extension that you had from your assignment last night in day 1. They taught you how to rationalize a more complicated fraction that has a binomial with a radical in it, or maybe 2 radicals in it. And so the way to get a radical, the inverse of square rooting a number is, the inverse of square rooting a number, taking the square root is squaring a number. So this process helps you square a number. And because it's a binomial, they used a really familiar pattern that you should recall. And the pattern is the blank and blank pattern.
The sum and difference.
Good, the sum and difference pattern. The sum and difference pattern is the one in which we end up with the difference of 2 perfect squares. We learned this back in chapter 9. So here's kind of the model of our sum and difference pattern. The sum and difference, when you multiply factors that are the sum and difference, the outside and inside are opposites, remember? The outside is negative AB, the inside is positive AB, so you end up with no middle. You do not end up with a trinomial. You end up with the difference of 2 perfect squares. And because we're using radicals, and we want to remove a radical, squaring it is perfect. We can remove a radical by squaring it. So here's our first example. We have 3 over the square root of 7 plus the square root of 6. Now, can we just combine the square root of 7 plus the square root of 6 and call it the square root of 13? No, it does not work that way. We do not have an addition of radical property like that. No. If they were both the square root of 7, we could call it 2 square roots of 7, but that's not what we have here. Okay? So, knowing that we're using the sum and difference pattern, let's make this look more like the binomial that it is. It's 2 terms being added. That is the definition of a binomial. And so, this is obviously, it's the sum of 2 things. So, who can give us the conjugate?
The difference.
The difference, right. The difference would be what? Can you give it to us?
Minus.
It would be a minus, and it's these same exact terms, isn't it?
Mm-hmm.
So square root of 7 minus the square root of 6. And if we're going to multiply the denominator by that, in order to maintain equality, we have to multiply the numerator as well. We're really multiplying by a gigantic 1, right? This 1 is really tricky looking because it's a binomial.
Why don't
So let's just look at the denominator and see what we have. If we take the first term and multiply it to the first term, what is the square root of 7 times the square root of 7? Square root of 49, which is 7. Good, 7. And then we have the square root of 7 times the square root of 6, but it's negative, right? And that's negative square root of, you could call it square root of 42, right? Negative square root of 42. And then what do we have here? Positive square root of 42. So those opposites eliminate the outside and inside. And we're left with negative 6, right? Square root of 6 times the square root of 6 is the square root of 36. It's just our familiar pattern. In the numerator, we're going to distribute the 3. So what is 3 times the square root of 7?
20?
It's 3 times the square root of 7, right? Okay?
You can multiply.
It's outside, this 3 is outside, it's not in a radical. If you need to put a coefficient in front of this radical, it would be 1 square root of 7, right? So we have 3 square roots of 7 minus 3 square roots of 6. Okay? And now, can we combine 3 square root of 7 minus 3 square root of 6? Those are different terms. If they were both square root of 7, we could combine them, but they're not. So we can simplify the denominator, though, and call it 1. So 3 square root of 7 minus 3 square root of 6 over 1. Oh, which is just 3 squared. We don't even need that, do we? It's just 1, so I'm going to erase it. And there you go. There's our simplified answer. Okay, B. Again, it looks almost like, what mistake might a kid make with this one? Do you see it? Right, canceling. But it's not multiplication. We have a binomial over a binomial. So you may not cancel 7, square roots of 7 here, right? This entire thing is the divisor going into this entire binomial up here. So we're going to have to remove the radicals from the denominator by multiplying using sum and difference pattern. So what is the conjugate, the binomial we need? Summer.
I got square root of 7 minus square root of 2.
Good. And so we'll have to multiply that same binomial to the numerator in order to maintain equality, right? Okay. So now we multiply across. So square root of 7 times square root of 7 leaves us with square root of 49, which is 7, right? And then look at the outside gives you negative square root of 14. The inside gives you positive square root of 14. So those are opposites. And then we have what?
So you pretty much never have to worry about those ones.
Outside, inside, now. And we have negative what?
2.
2. Okay? The numerator is tricky though, because it's not just a sum and difference, right? So what is the square root of 7 times the square root of 7?
49, 7.
So 7. And then the square root of 7 times the square root of 2
is 14.
So minus the square root of 14. They're both in the radical, so we multiplied them in the radical. Okay? Now we have one of these, 1 times the square root of 7, positive, square root of 7. And we have 1 negative square root of 2. You see that? So minus the square root of 2. Now, are there any radicals in the numerator that are like terms?
No.
Doesn't the 14 and 7 feel so like, or there's something?
No,
But
the
can
one's
you cancel
negative.
the
one.
7 and the 7 and the 7?
No. Well, okay, first of all, there's addition and subtraction, right, Talia? So you may not, only when there's all multiplication may you do some canceling, right? What is 7 minus 2? We'll just call the denominator 5. Okay? Now, is there any perfect square factor in the square root of 14?
No.
It is 2 times 7, so there isn't. So this is a simplified form. And does it look simpler than the original black expression that you see there?
No.
But it's simplified because there's no radical in the denominator. So tricky problem. Okay, let's go and continue to practice multiplying radical expressions. Remember, you may only multiply radicals, what's in the radical with another factor that's in the radical. So this is interesting. So what property will we use here? Good, the distributive. So the square root of 3 is being multiplied to both. Did I just get bumped? Okay, so the mistake would be, somebody would say the square root of 3 times 2 is the square root of 6. That would be a mistake. The 2 is not in the radical.
I want to
Okay, so tell me, what is the number in front of this radical here?
1.
1. So if you need to put that invisible coefficient or whatever out there, put it out there. You may multiply this 2 by the factor out here that is not in the radical. So what do I have when I multiply square root of 3 times 2? I have 2 times square root of 3. Good, 2 times square root of 3. Now when I multiply the square root of 3,
I don't get it.
Square root of 36, 6.
Good. I have the square root of 36. And the square root of 36 is 6.
You go too fast.
Jocelyn, how do you think we might simplify this question?
I don't know.
Well, you have a binomial and a binomial. What is that little acronym we've often used? FOIL. Okay, so we might do the first term here times the first term over here. We're just distributing square root of 2 to both of those
What
terms.
they're like, so you can make them a square.
What is the square root of 2 times the square root of 2?
4, but it's 2.
But it's 2.
Okay, so if it's confusing to you, you could do a lot of expanding. you can write it like this, square root of 2 times the square root of 2. Which she says is the square root of 4 and has called 2 now. Now, Jocelyn, we now have this. We have the square root of 2 times -3 square root of 5. Okay? Those are the two factors we're now multiplying together. So you may multiply the square root of 2 with which of these numbers here? The -3 or the 5?
Wait, what?
The square root of 2 times -3 times the square root of 5. The square root of 2 times -3. The one is in a radical, one is out, right?
5.
Times the 5. So we would call this what?
Square root of
-3 is one factor there.
10
Times the square root of 10. Good.
plus the square root of 10.
Now we're going to do the next square root of 5 times the square root of 2. The square root of 5 times the square root of 2. We can write it like this if you wanted to expand it. But most people don't want to do all this writing, but what is the square root of 5 times the square root of 2?
square root of 10.
Good. And then the last terms give us the square root of 5 times -3 square root of 5.
Wait, what?
So it's negative, look at here,
5 times the square root of 5, 25, which is
Yes.
5, and then it would be -3.
times 5, which is -15.
But
You've
you
got
put the
it.
square root of 5.
At this point, you're looking for like terms. So, is there a like term to the integer 2?
Yes.
2 plus what?
-15.
-15 equals what?
-13.
-13. And then we have -3 square roots of 10. And how many square roots of 10 here? 1, right. So, how many in all? If I have -3 and 1 square root of 10, I have
-2 square roots of 10.
good.
How did you get 9? Is that 8?
Okay, I don't want you to write this down, but you're going to face word problems, and basically they're kind of a gift at this point. They do not expect you to come up with equations that have a bunch of radicals, but they'll give you equations with radicals, and then you are asked to do a few things. So you need to read. Sit up, Jack. You need to read, and then you need to apply what you've learned, and that's it. So they give you this formula that talks about how long it takes a planet to travel around the sun. One rotation or one traveling around the sun by a planet is called a period. And a period is given with this formula, P equals the square root of d to the third. And d is a distance in astronomical units from that planet to the sun at the average distance. It does not go in a perfect circle. There's extreme lengths and then there's shorter lengths, right? So the first question you just asked is, can you simplify the formula itself? Tara.
P equals C times the square root.
Good. And then they give you this 5.2 astronomical units and say, find it. Find how long it takes in Earth years for this planet to travel around Jupiter. And you just plug it in. So I'm not going to walk through it. You can plug in things
But where do you
yourself.
plug it in?
In for D. You
both
read
Ds?
carefully. Look at you read. D is the average distance. Oh, 5.2 is the average distance. You plug it in. You just read carefully and apply this. Okay? There's no question. One more problem. We're going to try just this last example as
No
practice.
one say anything.
And then, why don't you, if you're on the video, pause, see what you can do on your own, and come back and see what has transpired. There's no talking. 4 times 1, we have 4. 4 times, I see a negative, so I'm going to put it down. 4 times that is 4 times that. I cannot put them both in a radical since one is out. Then I have negative square root of 5. It happened one time, right? And then these two give me the square root of 25, which is 5. So this is actually -1 square root of 5. This is -4 square roots of 5. So together they're -5 square roots of 5. And then 4 plus 5 is 9. Okay? So that's what you should have.